Hello class, this video is for the February 5th lecture. We'll be introducing basic shapes, drawing cubes, cylinders, spheres, pyramids, and cones. There is homework related to this class, 2 pages of cube-like objects. Try and get 3 objects a page just to fill the page, and then 2 pages of mainly cylinders, but if you want to put some cones or spheres on there, that'd be great. This is just to, check comprehension and following along with the video. It will be collected on February 7th, so again, 4 pages total. In terms of sketch tools and page size, as long as it's 8.5 by 11 or larger, it's totally up to you to decide that. All right, so we'll start off by talking about some cubes. This will be a bit of a refresher. Again, I encourage you to follow along. So, if you want to start by just doing a couple warm-ups, remembering to keep your wrist locked like if you're wearing a cast. Sit up straight, drawing most of these lines from my elbow and shoulder. We are getting into ellipses in this video, so it'd be a good idea to practice some of those. Most of my motion as I draw these are in my forearm. It kind of waves back and forth like a windshield wiper on a car as I go left and right, slowly moving my arm back and then down and back up as I draw these. So once you feel warmed up, we can get into drawing cubes. And for the sake of efficiency, we'll start by drawing 2 rectangles that we'll use as the majority of our underlays for the shapes that we introduce. I would recommend maybe using a blue Verithin. We'll probably get a lot of lines on this page, so if we keep it, switch up colors and draw light, hopefully we can keep things nice and clear. Again, I'm starting with the leading edge, going back to imaginary vanishing points to avoid distortion, defining my edges here, then where they intersect, going back to the vanishing points. And because they are imaginary, I'm basically just looking at, the level of convergence, how quickly the lines come together, making corrections as I see fit. I don't recommend using an eraser. It slows you down, but for the sake of clarity in this video and not getting too many lines, I may occasionally do that. Don't forget to rotate your page. I'm rotating my screen. I'm just not doing it within the program to avoid making you all dizzy as you watch the video. And it does help as we construct some of the other shapes to draw some of these lines in the back that we typically wouldn't see. I'm going to try, and keep this video short, so if I'm going a bit quick, feel free to pause as needed to follow along. There we have our first rectangle. The next one maybe we'll draw over here, lying on the ground. So again, starting with the leading edge, these lines checking the convergence of all the lines on the right, going back to the left here, checking convergence with those. It's not perfect, but just get it close. Define these back edges, and then go back to the vanishing points as needed. This is actually a bit lower. But then, once you have these rectangles drawn, I might come in a little bit heavier, with a little bit heavier pressure to just define the shapes. And I might actually take a fresh page over this. Again, I think this will be a useful page to use as an underlay, thinking about efficiency so that we don't have to keep redrawing these shapes as we introduce cylinders and cones mainly is where we will be reusing cones and pyramids is where we'll be reusing these rectangles. So the first part of the homework, again, if you'll recall, is these kind of like cube-like objects. So now that we have these rectangles started, maybe we'll take a fresh page and lay it down on top of this. Hopefully you can still see your line work underneath. And the way that we can make interesting cube-like objects is we can either subtract or add shapes to these forms. So mainly, maybe with this first rectangle here, we can subtract part of it. So the way I'm going to do that on my fresh page, I'm first going to start by lightly drawing in where my rectangle was, maybe just getting some of these lines just a little bit longer as they go back into the vanishing points. But then what I'm going to do, I'm going to draw a little rectangle in here. So I'm first defining this front face. This line is, going back into perspective. And where this top edge is, there's going to be a line going back to perspective this way. And I'm actually going to draw this back corner because it's actually the negative space of this rectangle that we want. So we want to see these, again, initially these lines that wouldn't be visible. I want to draw them on this rectangle because when we're done, we're going to turn this into kind of like a cube or a rectangle with a step cut out of the top here. So you can see I kind of have this rectangle constructed. It actually looks very similar to this one, just a lot smaller and drawn in alignment with the edge here. And now if I were to take, take my darker black Prisma pencil and darken the lines that I see, that I intend. So I'm going to leave this top edge out of the rectangle, but instead I'm going to draw this edge, I'm going to draw this back corner and this top edge. And if I come down here, the effect is I've now drawn a shape that looks like it kind of has a step cut in the top. And so now we have a cube-like object, but just by doing a couple simple additions, it's now a little bit more visually interesting than just a very basic rectangle. On this object on the right, I'm going to go back to my blue Verithin. Again, hopefully you can see your rectangle. Remembering to draw through on the shape. I'm going to bring this rectangle back into my fresh page. And on this one, instead of subtracting, we're going to add. So maybe I'll draw a cube on top here. So this will be my leading edge. I'll draw it a bit darker so that maybe we can see it a little more clearly. I'll define that as the top edge going back. We'll define the back edge here. There's, of course, a bottom edge going back to the left vanishing points. Then same from here. Now where these intersect, might be a line coming up. Now where these intersect, there's be a line going back to this vanishing point. Where these intersect, another line coming back to the left here. And again, if I now take my black Prisma and go darker over the lines that I see, I'm going to end up with a slightly more interesting shape than just a boring rectangle. Again, by adding a cube on the top. Shape kind of reminds me of those Tetris pieces where it has like a little block in the center. Obviously it's not quite equal. But there you go. By subtracting a shape, we have a slightly more interesting cube-like object, and by adding a shape, we also have a similar effect. If you're following along, this could be one of the pages of your homework. I might have another cube-like object here, just to add a bit of interest. If you want, you can practice subtracting other portions of it, see what that looks like. But essentially, those are the cubes. And again, that should be a bit of a refresher because it's very simple to project one. So the next objects we'll be getting into are cylinders. And I'm actually going to take a little bit of a deviation here and introduce how to construct a circle mathematically. Now, please don't stop the video. I know that math isn't fun, but the reason that we're going to talk about this process is it hopefully makes things more clear, because essentially an ellipse is a circle in perspective. So if we understand how to draw a circle and construct one two-dimensionally using straight lines, then it will make your life easier when you begin to construct ellipses in perspective. But hopefully, as you learn the process, I'll show you some shortcuts. You can kind of discard those tools and take some take some shortcuts, so it's not too painful. So to begin to construct our circle in 2 dimensions, you can start by drawing a square. So again, a square, the width, how wide it is roughly equal to the height. If you want to use a ruler for accuracy, you can, or take some graph paper. But once you have a square drawn, the first step to constructing our circle is to find the center of this square. It's going to be very similar to what we did in the past. We draw an X through the center. I'm actually going to correct this. It's just a bit too messy for me. Once we have the center figured out, I'm going to draw a straight line parallel to the left and right edges, and then another straight line parallel to the top and bottom edges. So we kind of have an X and then a T or a plus drawn in the center. Once we have this, we're actually going to use these to construct another square that's kind of like a diamond within here. So I'm going to connect where the straight lines intersect each other and draw this other square in the center, and hopefully this will be all clear in a second. So really this is all the construction we need to start to define the points where our circle is going to intersect. I'm now going to take my blue Verithin, maybe you were drawing with your Prisma there, and just to take a different color, and I'm going to mark points where the circle is going to touch. So firstly, the circle is going to touch these centers of the square. And the correct term here is tangent. Now tangent means that the line touches the circle but doesn't cross. To show what that means visually, if this is your circle, that line is tangent to the circle. They're touching but it doesn't cross. If I have a line that comes like this, obviously they're touching, but you can see it crosses into the circle. The way that I like to think about it is if you're drawing a circle and you suddenly stop and peel off in a straight line, that line is somewhat tangent to the circle. If you are drawing a circle and you kind of peel off at a corner, that line is not tangent. If I complete these circles, you'll see that the first rule outlined at the top is somewhat true. So again, those are tangent. Those are not. So that's what these dots represent. They represent a circle that will be tangent to these straight lines. Now the reason that we took the trouble to draw this sort of inner diamond is we use this line visually to find a spot that's halfway between the corner of the square and the line. So I'm going to go ahead and make those dots in here. So again, it's halfway between the line and the corner. And this is just a geometry trick. Once we have that figured out, we can start to kind of freehand our circle in. If you want to draw it slowly to begin with, circles are incredibly hard to freehand, probably the hardest thing to draw. Again, keeping your wrist locked, I like to start light and slow and then slowly build up. But if I want to take a drawing tool here just to illustrate mathematically how this works, I'll do my best to align it with the dots despite sort of my freehanding on this shape. But you'll see that it's pretty accurate. And we use this construction trick on our cylinders to get them to be as accurate as possible. So now we'll take our page again that we originally drew with the two rectangles on it and use this as an underlay for our cylinders. So again, imagine putting a fresh sheet over it. Hopefully you can see these rectangles. On this fresh sheet, I'm going to start by carrying these rectangles through. Again, it's all about working efficiently, using some work that we already constructed to help us construct some new shapes. It does help to draw these sort of hidden lines as we construct our cylinders, which you'll see in a minute. But just taking the time to draw these lightly. Defining where the edges are, and again drawing the back lines. But I'm really just, again, tracing work we already did. But now that we have our two rectangles, we're going to use them to construct cylinders. So again, using the trick that we just learned, where we construct, find the center, draw a plus, draw a diamond, and then get the dots for a circle, we will now replicate that in perspective on these faces. So I'm going to start with this rectangle that's lying on the ground. As we draw this, you can maybe think of a car wheel or a steamroller wheel. So I'm looking firstly at this front face, which let me just draw a bit darker to pull a bit forward. The first thing we're going to do is find the center. That last line wasn't quite accurate, so I'm going to just redraw that. Now that we have the center found, I'm going to draw a vertical line parallel to the edges. The line going through the center here is actually going to point back to the vanishing points. So it's going to go back that way. So now again we have our plus in the middle of our square, and if you recall, the next step after creating the plus is to draw the diamond. And the diamond is to bisect these lines so that we can find a midway point between the corner and the line, which I'm going to just go work my way around and draw those in. So halfway between this line and this corner, halfway between that line and this corner, same for this bottom. And then of course there's the tangent points where it meets, where it's essentially the corners of this diamond. Once we have these points defined, we can start to ghost in our ellipse, again trying to keep it tangent to the edges of the square. And you can see it's a bit of a squash circle, but it's slowly getting heavier and thicker on the line weight. And then we're just going to mimic that same thing on the back here. If all that math stuff seems a little bit confusing, let me maybe show you a shorthand here, or if maybe, or maybe better stated, if that is clear to you and you just want to shortcut all those steps, you can think of, it's really these main points that matter. If you can draw an ellipse within here that's tangent to these lines, you can get away without having to draw that diamond in the middle. Again, it's just knowing that you hit these centers and it is somewhat tangent. You can also, if you don't want to take the time to draw the diamond, it's about, what is it, roughly 3/4 of the way from the center to this line. But you can get that back ellipse pretty quickly. And now that the ellipses are drawn, you'll actually see that, roughly here's the major axis, here's the minor axis. That's true here too, major and minor. And once the ellipses are drawn, to complete the cylinder, we're going to draw a line that's going back to perspective, back to the vanishing point, that's tangent to both ellipses. So again, tangent is touching but not crossing. So it's kind of like a line that comes up here and peels off smoothly and meets with this ellipse and blends into it. So same thing, coming down, peels off smoothly. You can also think of it as like almost parallel to this edge. Same here. And now if I wanted to complete my drawing, coming with my darker very thin pencil and drawing over this, I can now complete the illusion of my cylinder or steamroller wheel in perspective. If I wanted to then duplicate this, I could draw another cylinder standing up here, so maybe a can of soup, using the exact same process. So there's a slight difference here because the ellipse exists on a horizontal plane. The bisecting lines point back to the vanishing point. So we'll repeat that process here on the top. So again, we find our face that we want to draw this on. We then find the center by drawing an X. We then, now that we have the center found, I'm going to connect the center to the back vanishing points, first to the right vanishing points and then to the left vanishing points. And then now that these sort of edges of the square are bisected, I'm going to connect them to draw this diamond shape in the center. And if you recall, the diamond shape is used to find the midway point between the corner and the edge of the diamond to draw our dots. This back corner is a little confusing because it's kind of foreshortened, so it's really just kind of in the center there. And then of course the tangent points, which are the corners of the diamond. And then now that we have our 8 points, I'm going to come in and slowly draw the ellipse a little bit darker. And there's our ellipse on the top. We'll repeat that same process on the bottom. Again, if you want to, shortcut it, once you find the center, I realize the center on the bottom is a little confusing because this leading edge is almost in alignment with it. But again, the center goes back to both vanishing points. And once we have our centers here found, again, we can kind of, if we don't want to bother drawing the diamond because it takes too long or maybe it makes it too complicated, we can kind of just ghost in our ellipse, roughly knowing where it goes. But here you can see very clearly that here's the major, here's the minor axis. We can see that on the bottom here, major, minor, and ghost that in. And then same as we did on this cylinder on the right, we can connect this bottom ellipse to the top with a tangent line. These lines should be vertical. And then if I take my dark Prisma to finish off this can of soup, I can get my ellipse on the top, my bottom edge on the bottom, and connect them smoothly with tangent lines. A common mistake that I see is it's easy to, you might draw like a line like this and then have a line coming straight up like that, and then you're going to get a corner there. Try and get that transition here to be like as smooth as possible. Again, we want it to be a tangent line that nicely blends and goes vertical into the edge of the cylinder. One thing you'll notice on these ellipses, and this is a good property of ellipses to know, is that ellipses that get closer to this horizon line are going to have a shorter minor axis. So the closer you get up to the horizon, the tighter that this ellipse is going to be. If the ellipse was like on the horizon, it would just be a straight line. So if I drew a cylinder here, it looks kind of funny. And we'll get into this on the second project when we talk about composition. But essentially that would be the top of that cylinder. The further you get away from the horizon, the lower you get, the more circular the ellipse will get. So an ellipse down here would have an even bigger minor axis. So just like we learned with this sort of trick in drawing in perspective that objects in the foreground are bigger than objects in the background, a good trick to know with ellipses on a horizontal plane is the closer they get to the horizon line, the more squashed they're going to be. So if I represented that with just a quick illustration, it might look something like this as you get away from that horizon line. And that's just a good shorthand to know. It's just a quick trick. For example, if you're drawing a water bottle, you'll know that the top where the cap and maybe the drinking spout are all going to be more narrow than the ellipse, or have a smaller minor axis than the ellipse on the base of the water bottle. If you were to reverse it, you'll see it's going to look really funny. It's almost going to look like the water bottle the cap is like leaning forwards and coming towards the viewer. So just kind of knowing that trick is a useful shorthand for drawing ellipses, and that way you don't have to. Really, the construction that we just went over with the rectangles is a way to get accuracy and just a way to learn cylinders. But once you figure out the basics, you can definitely take some of these shorthands and not have to worry about going through all of those steps. So hopefully those cylinders were clear. That was definitely probably the most complicated object that we're going to learn how to draw today. If you're able to understand ellipses, then these next couple objects should be a little more clear. The sphere is a unique object in that it's both really easy to draw, because no matter where it's located in your drawing, it's going to be a circle. But that can also add to complexity because it's kind of hard to define. I'll get a little more into that on Wednesday. But for now, we'll just do a basic introduction to it. So again, if you want to take your blue Verithin, unfortunately we can't use our underlay of the rectangles here. We'll have to draw a cube. And that's due to the property of a sphere. A sphere is a perfectly round object that no matter where you measure, if you measure from one point to an opposite side, no matter where you measure from, that's going to be equal. Again, provided you go from one point to a point opposite on the opposite side of it. So in order to accurately represent that, it helps to start with as close to a cube as you can draw. Again, just judging by eye, trying to keep all the sides, roughly equal. And we're going to use some of the same tricks we just learned on this cube to draw this sphere. So if you recall, when we were drawing the ellipses, we were finding the centers of sort of these straight lines. If I take the centers of sort of this outside edge of this cube, and I draw curves tangent to all of them, and try and get a circle, essentially I start to represent a sphere in space. The cube is helpful to kind of define where the where the sphere exists in space. This is definitely more useful when we get to the third project, when we get into some shadows. The more complicated way to define a sphere, and this tends to happen when you want to subtract from it, is when you need to start to define sort of these center planes and center axes. So for example, if I wanted to draw, an orange with a wedge, a quarter of a wedge missing, that's when it might be useful to kind of have, or maybe a Pac-Man. That's when it's helpful to have some of these internal internal ellipses defined. But essentially for now, it's sufficient to say no matter where your ellipse is in space, it's going to be a perfect circle. Again, it is just the property of the ellipse, or of the sphere, and just the nature of the geometric object. So again, a pretty easy one. Doesn't hurt to have a cube to help just define where it exists, and keeping it tangent, to the outer edges of the cube. Next up, we have the pyramid and the cone, and once again we can use the rectangles from the first page that we drew as an underlay. So just putting a fresh page over it, start the same way we started all the others, with just roughing the rectangles in place with light lines with your Verithin pencil. Don't forget to rotate your page. You'll get slightly more accurate lines that way. Starting with pyramids. So pyramid and a cone, they're very similar. Pyramid is based off of a prism, so a shape with corners. Obviously it could be like 4-sided, 3-sided. A cone is based off of an ellipse, so it's softer. If we start by looking at pyramids on our new page, if we define the bottom of our pyramid as a square in perspective, it could be this bottom face. All the edges then come to a point. So if we want it to come to the center, we can find that center with an X from this top face. And now I can just draw straight lines coming to this dot that we created. And again, if I take my black Prisma pencil, or maybe my black Flair or Sharpie, and go over, I now have a pyramid. I can replicate that same step on a pyramid lying on its side. So if it's maybe pointing away from us, this is the back face here. We find the center of this face on the opposite side, and then once again we connect the corners to that center. take the darker drawing utensil to kind of define it. We now have a pyramid pointing away from us. It is, of course, floating in space. Now, if it had a shadow, be on the ground like that. Again, we don't really get into shadow. We don't get into shadow until project 3, so that's the next segment. For now, it's just learning basic shapes. Cones are the same thing. Again, using our underlay page. It's very similar construction with the exception of using a shape for the base. We're going to use an ellipse for the base. So again, if we want to use an ellipse shortcut, so if this is a cone, maybe this is an ice cream cone. So let's say the ellipse is on the top here. If I don't want to take all that time, and I'm just going to find the center of this square here, this square in perspective, and I'm just going to draw my ellipse tangent to all these lines. I'm then going to find the center on the bottom here and connect straight lines to this center point, tangent to this ellipse on the top. Now with my darker pen or pencil, I can come in here and define my ice cream cone. Now maybe it's melting a bit. Same thing here, maybe this cone is pointing at us. Maybe it's a traffic cone lying on the side or something, but I can define the center. Again, if I don't want to take the time. If I recall correctly, the major axis goes that way. I can find the center of this face, which is roughly here. I can connect the center to tangent lines to the edge of this ellipse. Draw with the darker pen. The shape, I think I said it was a traffic cone, so maybe it has this flare on the back. It is, of course, floating in space, though, so the shadow would help define that it's floating. But essentially, those are the two cones that we have. So yeah, there you have it, pyramids and cones, pretty simple. In conclusion, we learned how to draw a cube, which was really a refresher of what we did the first project, starting with the leading edge, going back to our vanishing points. The cylinder is really the main focus, is learning how to draw accurate ellipses by dividing up a face and turning it into a proper circle in perspective, and using that to construct the ellipses using the major and minor axis. A sphere, once again, is really just a circle anywhere on the page. There's a little more to it, but for this project, that's sufficient to know. Again, it's helpful to maybe at least use a cube to construct it, just to kind of define where it exists in space. And pyramids and cones are really just connecting bases of cubes or rectangles to the center of a different face. Of course, the difference between the two of them being that one is constructed from an ellipse and one is constructed from a shape. Hopefully that's clear. Don't forget 4 pages of homework. If you have any questions, feel free to text or email me. I'll do my best to get back whenever I can, and I will of course answer any questions on Wednesday and do a quick recap. Thank you for following, and have a good day.